Hello everyone, today we're gonna present our project on identification and classification of thyroid disease using deep learning methodology, and our project guide is Dr. C.SHOBANA Nageshwari, Associate Professor, and myself Swastika Sharma, and my teammate is Yashida Devi, and we are from RMD Engineering College. The reason why we chosen this project is because thyroid detection is one of the most complicated problem that medical officials face. Looking at X-ray image, it is very human specific thing wherein an endocrinologist take a look at the image and decide the patient has thyroid disease or not. It is quite possible that due to human error, there could be some cases which will be missed which will lead to eventual problem. Previously, artificial fish coupled with the uniform design algorithm are used where the profile and peak of the spectra were very similar between two groups, and this algorithm need longer time to train dataset. And also electric light scattering spectroscopy are used to show the difference between normal and abnormal thyroid. In existing method, online transfer learning algorithm is used to diagnose the normal and abnormal thyroid nodule from ultrasound image. Here the main disadvantage is that it works if the initial target problem of both module are similar enough and only detect the normal and abnormal of the thyroid present, and accuracy decrease with decrease in the amount of data. To overcome this defect, we have proposed novel deep learning modified resonant algorithm to detect thyroid disease to predict the highest accuracy of 6 different types of thyroid disease. Now we're moving on working flow diagram of this project. Initially, the first step we will be having a dataset collection where we collecting datasets such as X-ray or CT image to analyze the presence of thyroid disease from various resources through internet. After that, we will be splitting those datasets into different categories. That is, we will be splitting into training and testing. 75% are used for training the dataset and 25% are used for testing the dataset when it's been completely ready. So training dataset first undergo the process called data augmentation, where the dataset is multiplied into many datasets. Then it will be given to pre-processing, which is make all size into single size. We train the dataset by extracting the features using a novel deep learning architecture. It undergoes a process called optimization, which will optimize the model, and loss minimization, which will reduce the noise generation during training. In the last, it will be undergoing a process called model segregation, which will be evaluated after generating a model using the testing dataset and predict the presence of thyroid disease. These are the pre-processing result. We can see center portion has been enhanced and outer area has been reduced. Deep learning use neural net with a lot of hidden layer and require large amount of training data. The most common image input parameter are image height, image width, number of channel and number of level per pixel. Here, 3 channel of data corresponding to the RGB, red, green, blue pixel level are used from 0 to 255, and number of image width and height is equal to 100. One thing to ensure that image should have the same size and aspect ratio. In this project, we developed the API, Application Programmable Interface, using the JavaScript framework Node.js. Node.js is a server-side platform built on Google Chrome JS engine. Here, input API is run as a Python backend code. We have imported the libraries which are needed. The Flash library are used for front-end and back-end for data and image transformation. After we initialize get and post method to initiate the input URI function, which is mainly used for prediction. First, we will generate trained and model file. Then we fetch each database inside the class name. Now the image we are getting will be decoded. After decode, open with command will open an image, then cv2 imread will be given which will read the image. After reading and resizing a model .predict, we apply the prediction. Now output image which has been matched with the class name image that has been stored in a label variable which will print and send it to the front end. Here port 5008 for defining web application communication. Now for model file training process, first we import the necessary libraries to be used inside the code for processing. Next, we'll declare all the required variable and perform augmentation above all dataset image in each folder. Now we perform image pre-processing on all image and resize it to the required size and separate the dataset into training and testing set. After training dataset with the declared variable, we'll apply optimization and loss minimization during training process to eliminate the losses. Now evaluate the model generator after training process. Here retrain the obtained output, changing the optimization technique, and save the model file and get the prediction output. Now we will show you the output of our project. Here in dataset collection involve the process of collecting 6 different types of thyroid disease dataset. The 6 different types of thyroid disease are thyroid cancer, thyroiditis, thyroid goiter, hyperthyroidism, thyroid nodule, and thyroid normal. In prediction with the API command execution, we give python input underscore API.py where it runs as a Python backend process. Then we will minimize the command window, and in order to run the code, first we need to go inside the project folder and select the location to run. Here we go inside the React folder, command execution, and type npm start. As the code is run, the execution begins where the dataset are trained using the novel architecture and the achieved and accuracy has been printed. Now, thyroid login web page is successfully developed using React.js. Here, user can sign in their account by giving username and password to perform the diagnosis. Once the user successfully logged in, the home page is displayed to the user. Now, the user can upload the image through the web page. The user can view among the different types of thyroid disease which thyroid cancer the patient is suffering from. Likewise, in this web application, we can diagnose different types of thyroid disease and get consultancy with doctor. Thus, this method provides an effective and cheap method to determine the presence of thyroid disease than the methodologies used nowadays. This is the graph which is generated after training process. Here, accuracy is actually the label provided by y-axis and epoch is the label generated assigned to the x-axis. Here we can see trained losses and validation losses is shown below, and the training accuracy and validation accuracy is shown above. So our accuracy is 95% and each epoch would show you the percentage of the output. We can upload another thyroid scan report from the browser. After submitting, we can get the desired output.